Sure, thank you so much for your suggestion. Yes, we will also provide the video later and the demonstration. All right, thank you. Good afternoon, everyone. Welcome to today's ARDaC training. My name is Mainting, and I'll be hosting today's session. Before we got started, I want to let everyone know that today's session will be recorded. So we will share the recording with everyone after the training. Then you can review the materials and demonstrations later. This is our second ARDaC training session. Ever since the first training happened last September, we have updated the portal and added new data and features. So today's session will focus on what has been changed and how to use the updated system. Next page, please. I would like to briefly introduce today's instructors. Hao will lead our portal demonstration and walk us through the updated features. And I'm Mainting, the ARDaC project manager. I'll be hosting today's session. And Carla is the director of the data core. Dr. Jing Su is the director of data commons and provide the ARDaC overview and portal updates. Dr. Wanju Tu is the IUDCC PI and provides overall leadership and support for this project. And today's agenda, we will include the ARDaC overview, the updated portal walkthrough, and then Q&A session, and also a short survey at the end. So please feel free to either drop your questions into our chat box, or we can save the questions for the Q&A sessions. And now I'll turn it over to our Dr. Jing Su for the ARDaC overview and portal updates. Hi,
Yeah,
Dr. Su.
yeah, thanks a lot, Mengting, and welcome everyone. So here's a very brief overview of what ARDaC is. ARDaC stands for Alcohol Research Data Commons. Uh, Its mission is to serve as the data center for the whole AlcHepNet consortium and as a collaboration hub that encourages collaborations across our consortium and also as the innovation engine to generate new hypotheses, inspire new studies, and guide new proposals. And of course, the ARDaC will gradually opening to the whole research community beyond our own consortium. So the current data resources are from the AlcHepNet phase 1 study. There is included an observational study and a randomized study. We start to incorporate treat studies. Currently, we incorporate the study 001, which is an observational study. In the future, once the ITOD trial finished, its data will also be released on ARDaC, and we are working on the incorporating more external studies to enrich the ARDaC data. And for data domains, we currently mainly focus on 3 types of data: clinical data, biospecimens, and especially biospecimen availabilities, and also lab assays. We start to host translational multi-omics data. And the ARDaC Common provide a research and a data hub that allow different labs to work together. And the data are incorporated through the ARDaC data standards, common data model, and through the graph data model. And this allow incorporation of data from different studies to provide a universal interface for query, visualization, and data analysis. And the one exciting part of this data release is that this is the first release of the Energy. Energy is the AI and machine learning engine for ARDaC. It allows the ad hoc query and exploration, and then generate visualization and reports using AI statistical model and machine learning models. And also it help access management, and later on it will provide online cloud analysis. So the ARDaC follow the fair design principle. It incorporates NH common data elements. It utilized the NH GDC, the graph common data models, and it follows the J4GH global data standards. So the data on ARDaC through these data standards can be connected with the REST data that are following similar data standard in the NH data and research ecosystem. Next slide, please. Yeah. Now I would like to introduce the intended use, do's and don'ts. So first of all, ARDaC provides the interface for you to browse the data, to explore the data, and to explore biospecimen availability, and then help you to develop some hypotheses, and then to prepare your proposals, either for data analysis or for the plan of generating data from the biospecimens. And then once your proposal get approved by the proposal publication subcommittee of the consortium, you can request the data download, and then you can get a copy of the data, and so then you can conduct research on the data. So the system access roadmap is in 3 phases. The first phase, we has already passed it for invited users to test our system. And starting from now, the ARDaC is open to all AlcHepNet investigators. So welcome to spread the news to your team and your colleagues inside the consortium that they have the access to ARDaC now. And in the future, gradually we'll open ARDaC to the external users for the whole research community. Next slide, please. The current status, as I mentioned, that we are expanding the data, including treat data, including mobile specimen conditions, situations, model lab results generated and contributed by the translational labs. We are including more outcome results, especially adverse results, into the ARDaC, and we start to host multi-omics data. And I would like to emphasize again that the antigen now is functioning, and we already built the R and Python microservices that can run most available biostatistical, machine learning, or AI models. So with the antigen working now, we are surveying our users about what's the most needed AI models, machine learning models, and system models you want us to incorporate into Antigen so they can use such services for your data visualization and analysis. And I also want to mention that we are providing industry level help desk support. It's a 24/7 support to support your access, and we are performing comprehensive trainings, including side training sessions, online training, and other training opportunities to support our users. So we are still growing in data, in the user access, and to demonstrate our impact in the research community. So the next slide, please. Yeah, so for this training session, please feel free to explore and send us your feedback and help us to improve the system. And we'll have a survey sending out. Take your time to explore the system. And when you get ready, please do fill in the survey back to us. That will help us to help your needs. And these training materials will be distributed in several different ways. This training session will be recorded and shared on YouTube. Meanwhile, we will share a demonstration to demonstrate how to use the ARDaC, also be shared on YouTube, and our training materials will and the documentations will also be shared on GitHub and on our website. It's a link that will be provided at the end of the training. Yeah. So let's go to the next session. So how will lead the next session? Yeah, how please.
Thank you, Dr. Su. Hi, everyone. I'm Hao. Today, I will focus on the ARDaC demo, and I will show you the new features and walk you through how to use the portal. So for today's training, please use the training link shown here, and the official link is also listed. And we also provide the archive link in case anyone needs to compare with the previous version. And before we start, one important reminder is the portal allows users to explore the data interactively, but research use of the data still requires approval through the proper data request and the publication committee process. I think we will come back to that later. Okay. Okay, so uh, this updated version will include several important changes. So first, we have a new portal release that is moving through alpha testing and preparation for the official release. And the second, we have added treat 001. So that means users can now explore this new study data alongside the existing resources. And the third, we added energy report. This is a one-click AI assistant summary report function. And fourth, we are preparing portal usage pilots with the publication committee and the translational lab. Okay, so now the first new feature is the version tracking. So at the bottom of the portal, you can see the current dictionary version and the portal version. This is quite useful for two reasons. First, when the user report an issue, they can tell us exactly which version they were using. And second, when users write papers or documentation, they can cite the correct version of the data model and the portal. And the links here connect to the GitHub repositories for the ARDaC dictionary and the portal, so users can also check the version history and the source information if needed. Okay, another update
I'm
is
very
that,
sorry. I really couldn't
sorry.
understand what. Can you just go back to that slide?
Okay.
Because you said something about English, and then I'm thinking, so I presume all of them are only in English version. So I couldn't really understand what these two versions mean.
Okay,
Or would you rather I ask questions at the end, because I have other questions that I've been putting on the chat, but I can put this also maybe.
Yeah. Yes, thank you. So the dictionary version refers to the data dictionary we are using in this system, and the portal version, which means the interface. So which means the version in the interface layout and style. So these are two different versions. I hope this could answer your question.
Not really. So which one should we be using? The portal version, because that's where all the data is, correct?
Yes, if you want to use this portal, you can use the portal version, but the portal version is internally use the data dictionary in this version, because in our portal we are showing the data visualizations, and the data is organized in with the data structure, and the data structure is designed in the data dictionary. So you should, if you want to know how data is structured and designed, you should refer to the dictionary version.
Yeah, one example will be if you want to use an image generated on ARDaC to support your publication proposal or biospecimen proposal, set the portal version and the submission version so that this image you downloaded can be reproduced by the same portal and the same submission, which means the data version. And once you get the permission of downloading the data, in order to understand how the data dictionary looks like and how the data are organized and defined, refer to the data dictionary version here, so that you will always have the repeatable, reproducible results. Yeah.
Okay. Let me see. Okay, let's continue. I think another update is that we have added the new study data, which called the treat 001. Okay, so you can see it in the study name filter. This means users can now include or exclude treat 001 when exploring the participants, follow-ups, biospecimens, or lab results. We also listed some useful references on this slide. So if you are interested in the study design or study specific details, you can refer to these references after the demo. Okay, and the next major new feature is the summary report powered by Energy. You can find this red button on the right side of the Explorer page. This purpose of the function is to generate a quick report from the current data selection. So instead of manually copying the numbers and charts from the portal, now users can just apply the filters and then generate a report directly from the portal. This is the one main new features we want to highlight today. So here's the basic workflow of how to generate a summary report. First, you select a data tab, for example, participants here. And second, you apply filters on the left. The filters will define the current set of the records. And third, you click the summary report button. And after that, the report starts generating. While it is being prepared, you will see a status panel at the bottom right. And from this panel, you can generate multiple reports at the same time, and you can also cancel any of them whenever you need it. And when it is finished, the generated report will pop up automatically. This slide shows what will be included in a report. The report can be generated from 4 data types. They are participants, follow-ups, biospecimens, and lab results. And each report will include a cover page, raw information, selected filters, data statistics, visual summaries, and specific analysis results. So the important point is that the report will reflect the records selected in Explorer at that moment. So if you change the filters, you are changing the import records used to generate the report. This diagram summarizes the process from the filters to report, and the result here is a reproducible snapshot of what the investigator selected in the Explorer. And this can be very useful when users are preparing a proposal, checking whether enough data are available, or discussing a potential data request. Here is an example of a participant level agent report. You can see the top row gives quick summary numbers such as selected patients, participants, linked follow-ups, visit days represented, and the median clinical scores. And below that, the report includes visual summaries such as the alcohol use distribution by the visit day and the median trends over follow-up visits. And these numbers are example output. So the goal here is to show the report scope and format. And when users see this report, they should think of it as a structured summary of their selected data. This slide shows 2 more examples. One on the left is a biospecimen report using a serum filter. It summarizes selected biospecimens, linked participants, linked follow-ups, and the lab distribution. And on the right is a lab result report using a serum albumin filter. It summarizes selected lab results, linked participants, and the coverage of the related lab tests. And these reports help the investigators quickly assess whether the selected samples and the linked clinical or lab context are sufficient for a research proposal or data request. So the report is not only for presentation, it can also support early stage of the feasibility checking. Okay, so this slide just gave a high-level view of the Antigen architecture. As Dr. Su mentioned before, so Antigen works as a separate microservice in the Gen 3 system. It connects with the key components like GRP, Progran's Elasticsearch, GraphQL, and the data layer from the backend, and also the portal from the front end. And the goal is to support ad hoc query-based online analysis and visualization. So users can generate the summary reports directly from the portal just based on the data and the filters they selected. We welcome you to try this feature and share feedback. If there are any analysis, summaries, or visualizations that you want to see in the future reports, please let us know. Okay, so another new feature is the enable the download function under the data file tab. This means now users can download the manifest or metadata JSON file from the data file page. Okay, the last new feature is proteomics data resources. So proteomics related data are now presented primarily through the protein expression node. The protein expression records can be connected with related data elements such as molecular tests, aliquots, and follow-up context. So investigators can now use these resources to check the proteomics data availability and support translational hypothesis generation. All right, that concludes our walkthrough of the new features in this release. And now let's move into the basic portal workflow. We will start it with the login process. So this part is mainly for the new users who may not be familiar with our portal yet. So first, let's sign in. On the ARDaC homepage, look to the top right and click the login button. You will be routed to this login page where you can choose your identity provider, CI Logon or ORCID. For example, people from the Cleveland Clinic or NIAAA would use ORCID, and the others usually use the first one. And after choosing, you will need to authorize sharing your name and affiliation. That is how we map your role and permissions. And once you are signed in, you will land on the main dashboard. And before we move on, I will encourage everyone to log into ARDaC now and follow the steps with me during the presentation. Okay.
This is what we wanted to do, but I don't have power, so I have only one screen. So we have to do it.
Yes, that's fine.
I'm so sorry. No, I really was looking forward to this meeting because I wanted to learn. This is the best way to do it, which is hands-on. So
yeah, later we will provide the demo video so you can.
Yeah. Maybe I can use the demo video. Yeah. Thank you.
Yeah. Thank you. So okay, this is the main dashboard, our home base. Okay, so across the top navigation, you will see dictionary, exploration, files, query, workspace, profile, and Antigen. Now Antigen is currently shown as a disabled option because it is mainly for internal development at this stage, and it is not part of the regular user workflow yet. Dictionary, well, let's all data elements and their definitions. And the exploration is the core visualization tool for browsing cohorts and variables. And the files is designed for big data files such as omics or imaging data. It will link to the data files page, and the query will let you interact with the database using GraphQL, and the workspace will connect to the external tools. And the profile shows your account of information like the permissions and the API tokens. And on the top right, there are two useful links, submit data for the contributors and the documentation for how-to guides. You will also see your login status and the logout. And in the center, there are quick statistics, such as the studies, participants, follow-ups, and files. This gives you a quick sense of the scale of the data, and you can hover over each card to see more details. And next to this stats, there is a project summary box, which describing what ARDaC is and what type of data it has and its purpose. I think it is quite helpful for the first-time users. And at the bottom, you will find quick start buttons for the most common actions, like open the dictionary, go to exploration, launch query, or start a data submission. And whenever you want to return to this homepage, you can always click the AlcHepNet icon on the top left. Okay, now let's turn to data exploration. This is really the core feature of ARDaC. The page now you can see that it's organized into three main panels. So the tabs at the top will let you switch between domains like participants, follow-ups, biospecimens, lab results, and data files. And on the left, you have the filter panel. It is organized into tabs such as study, participant, behavior, outcome, and the lab test. And as you apply the filters, the counts next to each options will update in real time. And on the right, you will see the charts panel. It updates instantly when filters are changed. And you will see the top rows show overall totals, and below you will find more diagrams. And if you hover over the pie chart, you can see the exact proportions. So the whole flow is quite straightforward. Pick a domain, set your filters, read the updated visualizations here. And then if you want a more detailed report based on the current selection, you can click this red button to generate a antigen report. For more advanced usage in the filter panel, you can use this search box to find the filter values very quickly. And you can also use this setting icon to combine selections with and the or for more precise options. And as you refine the charts and the totals on the right will update to reflect your current selection. Okay, so scroll down to the table panel to see the row level records that match your filters. And you can see that these columns correspond to the data properties. And toggle this show empty columns button if you also want to see those blank fields. And this table is for a quick sanity check, just to confirm the raw data before the chart looks correct to you. Okay, now let's look more closely at the participants tab. As we know, on the left, the filters panel controls everything, right? So let's start with the study attributes. Here we have things like project, study name, groups in OBS, or treatment arms in RCT, and in the future we will have more trials. And then you can refine by the participant attributes such as demographics and clinical site. And beyond that, there are also filters for behavior and outcome and the lab test. Here are the outcome and the lab test filter tabs. Now you can further see that the numeric variables will appear as sliders. For example, here is the days to AKI. So you can set a range directly here. And for those categorical ones, they are checkboxes. And for labs, you can also select specific analyze to include, which counts showing how many records match. And once filters are applied, the results come alive in the chart and visualizations panel on the right. Now, under the participant tab, let's focus on the survival curve analysis. So here we customized a survival curve component with outcome options like overall survival and AKI, which means acute kidney injury. You can also group the curves by factors such as no grouping, observational group, treatment arm, or sex. And the table below shows the number at risk and the events over time. And if you hover over the curves, you can see more statistics at each time point, such as the survival probability. And note that for the clinical trial patients, the survival curve here is calculated from the treatment start date, and while for the observational patients, it is calculated from the enrollment date. And now you can see that I have set the outcome to AKI and group the data by the treatment arm. And each line here represents a different treatment group. And you can see that the small tick marks here along the curves indicate the censored observations. And basically, this chart gives you a quick way to compare event-free survival across the different treatment arms. Here you can see that if I have filtered to clinical trial only on the filter panel first, then you can see that the observational groups in the survival charts are excluded. So now the grouping is only by the trial arms. Okay, so now let's switch to the follow-ups tab. Here, the filters include things like assessment date and longitudinal scores. You can still narrow by participant attributes and then layer on follow-up metrics like the BMI, TRAL-Q, Leo, and so on. And you can also add outcome and lab test constraints as needed. And the right side will update immediately, as displayed in this page. And under the follow-ups tab, we also customize the four key liver function indicators. This include the MEL score, TRAL-Q score, MADRS discriminant function score, and the Leo score. Each of these can be visualized across visit days, either in box plots or spaghetti plots. Also, if you hover your cursor over the days, you can see more details. For example, the MEL score box plot here shows detailed quantiles and ranges. And by clicking this three-line icon in the corner, you can download the plot or the underlying data in a different format. Here are more custom views of the MADRS discriminant function and Leo. Now, let's move on to the biospecimens tab. Similarly, you can use the left-hand filters to define your cohort, starting with the study and the participant attributes. And then you can add biospecimen specific filters like specimens type or lab. And you can refine further by follow-up or outcome. And as always, the counts next to each option shows how many records match, and the charts on the right will update instantly. As displayed here. Here is an example from the Biospecimens tab. On the left, so under the lab filter, you can see that I have selected no not assigned option. That means these are available biospecimens that have not yet been assigned to or shipped to a lab. So on the right, you will see the breakdown, like over 50,000 biospecimens fall into this category, with the distributions by specimens type and the participant attributes shown in the charts. Here we turn to the lab results tab. As you can see, it comes with the filters for study, lab participant, lab test, and the outcome. And for example, you might filter results to a specific lab site, such as Nagi here. The chart will display the outcomes across the selected lab. And moreover, once you select a lab, you will see the corresponding biomarker plots. For example, here under the Nagi lab, you can view the results for urine, ALFA, BP, creatinine, to the IL-18, KIM-1, and to the NGAL. Each biomarker can be viewed as both box plot and overlaid spaghetti plots. And this lets you quickly evaluate how different biomarkers behave across these different treatment arms and over time. Here is another similar example. On the left, you can see that I first filter by lab and select the Liangpeng SQL lab. And then within that lab, I further select the ORM1 test. And on the right, you will see the distribution of the results. Okay, so the functions above are the most important on ARDaC, I think, and with them you can handle the most common tasks. And then the following section will cover the restricted functions. These are advanced features intended only for specialized users such as informaticians and data scientists. Okay, so first let's explore the data dictionary. The picture here shows the dictionary page. So the data dictionary basically displays the data model, which contains the nodes, attributes, and their relationships. So you can see that on the right, they are all the nodes listed with their names and their descriptions, and they are organized by the category. And this can also be downloaded in JSON or TSV formats. And on the left, you can use a search box for finding specific terms. And this feature is especially useful for validating your data structure before submission, making sure that everything matches the required model. Next, let's move to the graph view of that data dictionary. So on this slide, you can see the screenshot shows the nodes connected by links with different colors, which making the relationships between data elements very clear. And you can also zoom in and out to focus on details. And if you click on one node, like this, more information will appear, including its properties and parent nodes. And this visual mode helps you better understand how data is structured and connected rather than just reading from the tables. And now let's move to the query page. So this page allows the developers and data scientists to directly run GraphQL queries against the database. So first, you can input a GraphQL query in the left panel. For example, here we input the query for the distribution of patient age. And then you can click this run button to execute the query. And then the results are shown in the right panel in the format, including the max, mean, average, and the counts. And if needed, you can also switch to the graph model view for schema-based exploration.
Yeah.
Okay,
And
now
a quick comment is that you need the graph structure of the dictionary to decide how to write the GraphQL. So that's why the graph structure is provided to support your query. Thanks.
Yeah, thank you. Okay. Now let's come to the submit data page. This page is used to manage and upload new data into our system. At the top, you can see the list of projects with their case counts, experiments, articles, and files. And below, the recent submissions table shows the history of uploaded files, including ID, submitter, project date, file size, and submission status. And to upload a new data, you just click the Submit Data button, which will take you to the submission page. Okay, here is the submission page, and it will let you see the current data structure as a graph. As you can see that each node represents a data entity like case, demographic, aliquot, etc. They are all connected by their relationships, and you can use the upload file button to add new data files in TSV format, and these files must match the predefined dictionary structure. And the toggle view button allows you to switch between the simple view and this richer graph-based view, which helps you better understand how data elements are connected.
And also a quick comment is that currently the data submission function is only open to the DCC data manager. After review the data and upload the clean data, but we want to demonstrate that this capability is available and functionality is available here, just in case later on the users may be authorized to upload your own data. Thanks.
Okay. Here are the workspaces. So workspaces are where you can use the external analysis tools. So you can choose one and click launch to start a Jupyter environment. And from there, you can upload your notebooks, pulling approved datasets, and work in Python or R. And these functions are already available in our system, but they are not being open by default. So if you want to use them, you will need to put in a request and get approval first. All right, so lastly, we come to our profile page. Here, you will find the API keys that you can create, view, and revoke for script or app-based access, and you should treat them like your passwords. And below that, the project access table shows you like which projects you can use and what methods are enabled. So you always know what you are allowed to query or submit. Okay. Okay, so I think that's everything for the ARDaC demo part. Now I will hand it over to Menting, who will wrap things up. Thank you, everyone.
Thank you so much, Hal, for this walkthrough. Before we close, I want to highlight a few important points. First, at this moment, ARDaC is a platform for the investigators to explore the AHN data and understand what data are available. So there is a one clarification. Although the updated portal includes a download function under the data file tab, this is different from the general access to or downloading AHN research data. So for the AHN research data, users don't need the approval from the AHN publication and ancillary study subcommittee before IODCC can release the data. So for the questions related to research proposal submission, please feel free to contact Savannah. And for technical questions about the ARDaC access, please contact me at the ardac@iu.edu. Next page, please. So here, our team provided the cheat sheets that summarize the main functions covered today, including the antigen summary reports, survival analysis, follow-up score analysis, biomarker exploration, and etc. So you can feel free to use it as a quick reference when you are using the updated portal later. Next page, please. So here we also listed out the useful links and contacts, including our ARDaC websites, AlcHepNet websites, source code, training videos, and support emails. We will also share these materials with everyone after this training, along with our demo tutorial for sure. Next one, please. We also would like to make the final acknowledgement to support. We also want to acknowledge the support from the NIAAA, the Indiana University Data Coordinating Center, the AHN investigators, translational investigators, and Indiana University Genetic Biobank. We also thank everyone who helped today prepare our training materials, and thank you so much everyone for joining us today. So now we can move on to our Q&A session. Please feel free to ask any questions.
So can I ask a question? That session is very informative. And then one thing is I tried to access the account, but I have a hard time to access login, and then basically I cannot see the data.
Do you think, Dr. Kong, we did have your access? Could you please maybe provide us with a screenshot or share screen if it is convenient for you?
Right now?
Or you can provide the screenshot to me. Our IT team will dive into it. And Dr. Su, you are muted.
It's interesting to realize that there are two Louisiana in the in the log on. One is old, one is new. So maybe that's the reason. So but we will work with you offline to make sure that you can get access to all the data.
Yeah. Also, should I use the new or old? But in either case, I tried both. Still, I couldn't access the data.
Yeah, we can work offline to address this access issue. Yeah.
Okay, thank you much.
And also a question for the whole audience that do you want to use this opportunity for how to demonstrate how to log in and how to go through the different pages?
That will be wonderful.
Yeah, so maybe how you can, if the convenience for you to share screen and yeah.
Could you see my screen now?
Yeah, I can see it.
Okay,
Yes.
that's great. Yeah, so basically, this is the home page. You can see the overview, overall totals, and summary descriptions. And then you can go to the exploration, which is the, oh, sorry, I need to log in first. Yeah, so that's the exploration page, and there are several domains you can select it from. Now we are under the participants tab, and you will see the filters here, and they have different sub-tabs. And for example, if I select the treat 001, and you will see the visualization path is updated accordingly. And this is the table. For example, if you want to generate a summary report, you just click this red button, and you will see the status panel appear. And here you, and also, for example, if you go to next page, you can also generate another one. So here you can see there are two reports. Oh, sorry. Now it is generated, so it pop up automatically, and you can see this is our report, and here is the contents, and you can see the filters reflects what we have selected on the Explorer page, right? And this is the wrong information, and we will have data completeness. So there are more detailed than the portal visualizations.
And also, please recommend what's the most useful for you in this report, and you can easily add into this report, even for some complex machine learning models, biostatic analysis, or even AI models. If you are interested, let us know. We can incorporate it into the reports.
Yes. So we have visualization summaries, and also some specialized analysis results. For example, the survival curve. And because for the treat 001 data, I think the survival curve is not being calculated yet. Yeah, that's basically the energy report from the participant level, and
Yeah, another
also,
one is also generated.
yeah, another one is also generated, but I think it's this one. Yeah, this is the one from the follow-ups.
Yep.
Yeah. So and for other functions, I think
Maybe other visualizations. And,
okay,
yeah.
other visualizations are, maybe we can go to the yes, this survival analysis component. Here you can choose from different outcomes, like if you want to see AKI, and you can group by, for example, treatment arm, and you will see, and yeah, if you hover the cover, you can see more details and the statistics.
Yeah. And this ad hoc analysis according to the data set you selected from the filter.
Yeah. And for follow-ups, I think we can go to see more customized visualizations.
Yeah. For example, here the box plot shows the trajectory of those lab results. And if you have specific lab results you want it to show up on this this interface, let us know. We'll prioritize and show them here.
Yeah.
And
yeah, if you want to see more details, you just hover your cursor over these visualizations, and you will have more information.
yeah, for
And here is
example, if you look at the child pupil score between the two arms, the prednisone and anakinra, you can see the anakinra arm has the higher the child pupil score starting from day 7. That's something that you can quickly check. And if you are interested in a specific group, just select them from the filter. You can see what's changed here.
Yes, exactly. So
I think that we included the drinking behaviors now, right?
yes, let me see. Well, we put it. I think it's here.
Yeah. So this is the new data. We made them available. This show the drinking behaviors change.
And yes, and it's truncated at 500.
Yeah.
If you
For
hover,
example, yeah.
yes, I mean, if you hover over the plot, you will see more information. Just then look at it.
Yeah. For example, here we can show the heavy drinkers without alcoholic hepatitis drink more than the heavy drinkers who have alcoholic hepatitis diagnosed. So you can see those difference. Yeah. Okay.
Okay, so
maybe biospecimen availability part, which may be very relevant to if you want to apply for biospecimen to and propose to generate the data. So this table will be very useful for you. You can find how many biospecimens are still available if you click click the not assigned biospecimens. Yeah. So we currently still have 50,000 biospecimens not assigned or shaped. You can see the distribution of them. So you can start to think about ideas about how to propose the use of those biospecimens to generate the data. And you can also compare with what has been shaped and what data has been generated to consider about the synergy of your proposal with the existing data. So. Yeah. And so yeah, and also we can go to the data file to show the proteomic data that has already been contributed by Dr. Nagi's lab. So there are 2 proteomic data already being contributed for Dr. Nagi's lab. Thanks a lot. And we will include more omics data once we get the permission for data sharing from the PIs or data owners.
yes, and you can download them from this part.
Yeah, but please get the permission from the publishing committee first before you download any data here. Yeah. So we are on top of our 1 hour. So I'll go back to the Mengting. Yeah.
Yeah, thank you so much, everyone, for joining our training today. Thank you so much for everyone joining our training today, and we would be super greatly appreciate if everyone could fill out our survey. No rush to finish today because we want to make sure everyone has enough time to explore our portal. So please feel free to finish that within the next week. It will help us to improve, and it will help us to do better for our next training. Thank you so much.
Yeah. Thank you, everyone.
Thank you. And Dr. Cohn, do you may have a minute?
Thank you.
Thank you. Hi, Dr. Cohn.
Yeah, I can share screen. You can see
Yes,
what's
so we can,
kind of.
yeah.
Sure, let me stop recording. Sorry, give me
Okay.
1 second.
Let me see.
And our IT Alan.